Okay, looks like we're ready. Thank you for joining me this afternoon. I know this is the last session in a long day, and I'm kind of standing between you and dinner, or the bar, or whatever. So hopefully I'll make it interesting and make it worth your while. This mic sounds kind of echoey. Does it sound okay to you? Yeah? Okay. Okay. Well, so I'm Andrew Whitechapel. I work in the developer platform division in Windows Phone. So I'm responsible for some of the infrastructure pieces, the execution manager and the resource manager. And these are the things that control when an app or a background task gets to run and when it goes to the pause state and resume and terminate. And also the resource manager, which gates access to the contended resources on the device. So primarily memory, also CPU, and also some of the hardware sensors like the microphone and the speaker and the camera and the compass and so on. So I'm going to talk to you today about developing apps under constraints that are imposed by devices which don't have very much memory, or by scenarios, versions where memory is an issue, and other hardware constraints, particularly around screen resolution and sensor access. I've divided the talk into kind of 4 buckets. Why do you care? You know, we've given you the tools, we've given you the APIs. Why can't you just write whatever you like and leave the system to take care of everything else? Well, you can, but you'll likely end up with a suboptimal app if you do that. And so there are reasons why you care, which I'll go into. I'm making the assertion that one of the reasons that you're building apps is to target as wide an audience as possible. And you actually have choices about how you can do that. There are different ways to slice it, different ways to approach the problem. Then I'll look at a kind of a deep dive into what the resource manager does on the phone and why it does it. Some of this might be kind of uninteresting to you in the sense that it's fairly low down in the stack. It's not something you interact with directly, but it should give you some insights into why the phone behaves the way it is, why the cat matrix is the way it is, and what the constraints are that lead us towards this set of constraints. And then a set of best practices, the things you can do to live within the constraints that the resource manager imposes, or that the device imposes, or that the particular scenario imposes. So why do you care? As I said, I'm assuming that you do want to reach the widest possible audience with your app. And ideally, you want your app to run on every single Windows Phone device. But that's actually not enough. It's not enough to run on every single device. You actually want your app to run well on every single device. You want the user to have a really good experience of your app. It's not adequate to have it just barely running slowly and in a sort of glitchy way with features failing all over the place. You want them to have a good experience. You want them to continue to support your app, to get the new updates when you push them out, to get the other apps that you produce, to tell all their friends, to give you good reviews, to follow you on Facebook and Twitter, you know. But there are some constraints on the phone, more so than on other platforms, where this can be interesting. I was going to say it can be difficult, and it can, but I prefer to say it can be interesting, because it's kind of a challenge to you. This is a test of your geek creds as to whether you can actually produce an app that is optimal on all devices. Or are you a kind of lazy developer and you just kind of hack the thing together and you don't really care how it performs? Which I'm assuming none of you are, right? I have to be a little careful about the next bullet point, because there's sort of political implications of this, but the vision of a single platform so that you can build an app which would target Windows desktop, Windows Phone, Xbox, potentially other arbitrary devices, I think is actually a wonderful vision. But it obviously comes with constraints, particularly on a mobile device. We're basically talking about, we're converging in the ways that make sense wherever we can with the desktop OS. That means a desktop OS on a mobile device. And desktop frameworks and all the desktop services that go with it. So it is difficult to make it fit, I mean, from our perspective. Hopefully we've done enough of a good job so that a lot of the pain that we experience down in the infrastructure is kind of transparent to you. But we've done some work, but there's more to do. I mean, as I say, we've brought it up to a certain level, we've given you a base platform, but there are still things that you can do in your app to optimize your app's behavior. With these constraints. And the little pie chart on the left kind of gives you an indication. This is the latest data that I have on the split of devices running Windows Phone. And it breaks down roughly 50-50 between 512 meg devices and 1 gig devices. Actually slightly more 512 meg devices. Tiny amount of 256, those are obviously old Windows 7 devices, and an equivalent tiny amount of 2 gig devices. And the trends seem to be that the 512 segment is growing in relation to the others. So if you are aiming to target the widest range of devices, or the biggest market, you probably want to be focusing on 512. Seems almost counterintuitive, but those are the numbers. And the last point at the end is also quite important, that you can build an app that kind of hogs the system up to a certain point. I mean, we cap you off at a certain point, but you can still build an app that's kind of reckless and make your app perform reasonably well to the exclusion of everything else on the phone. Because, you know, the classic scenario is that the user runs your app. What they do is they kick off, say, video download from Netflix, or they kick off email sync, or something that they expect to continue to run in the background, and then they run your app. And if your app is well behaved, it won't use all the memory on the system, it won't use all the CPU on the system, so the background tasks can continue to run. What you don't want is to have the experience where the user runs your app, they come back to check on their Netflix download, and they see that it hasn't actually progressed from where they left off. And they'll fairly soon get the message that it's your app that's the problem, it's not Netflix. So you do have a responsibility to play nice in the ecosystem. So ways you can do this, fairly arbitrary divisions, breadth targeting. By that I mean target everything, every device. Selective targeting, you choose a subset of devices that you want to target, and there are various ways that you can choose that subset. Both of those are kind of static options. Feature light up, by that I mean conditionally enabling and disabling features at runtime. So it's not a static choice. You look at what you're running on, figure out how much memory you've got, figure out what the configuration of the device is, what sensors are available to you, and then you either enable or disable features, or you tune features. You have an enhanced feature on a device with more capability and a sort of degraded experience on a device with a lower capability. And broad multi-targeting, all I really mean there is if you're in thinking about ways to slice your market and ways to shape the target, shape your app for the target audience, then another thing to think about, a kind of an extra dimension is, do I target, say, Windows Phone 7 and Windows Phone 8? And do I target Windows Phone and also Windows? So there's another dimension to this decision there. So breadth targeting first. This is an option, and it's the simplest option. So aim for the lowest common denominator. Aim for all possible devices. So in order to do that, you're going to have to curtail your feature set. That means you have to restrict your app to those features that are only available on every single device. And that means not just software features, but also optional sensors, for instance. You cannot use an accelerometer. You cannot use a front-facing camera because they won't be available on all devices. Well, that's an option. It's the simplest approach. You just reduce yourself down to a subset of the total features, and you're done, pretty much, and that will always continue to work. And for some set of apps, that's a perfectly valid approach. But probably a very small set of apps, because you are explicitly excluding features and excluding capabilities of the device. So for most apps, that's probably not a good choice. If you want to target a subset instead, you can do that in various ways. You can go by version. You can say, well, I'm only targeting Windows Phone 7, or I'm only targeting Windows Phone 8, or both. And remember, when you publish an app in the store, you can maintain multiple versions or a single version. So you can either have a single version that targets multiple platform versions, or you can have multiple versions of your app. And you can maintain them separately and update them separately. And in the same way, you can obviously slice your market by other means, like by region, for instance. If there is a capability that requires you to have a certification, like a game certification, for instance, and you don't have it, or you don't have it for that particular region, then that kind of, by default, restricts your spread there. And there may be, you may decide for other reasons, like commercial reasons, that you're going to make the most money in the Eurozone. So you target that region. You've obviously got choices there. Device capabilities and requirements, almost the same thing, slightly different, but you can specify ID cap, whatever, to say that this app requires a compass, or this app will use a compass, or this app will use an accelerometer, or this app will use networking, or the web browser control, or whatever the capability is. And all that happens there is that information is surfaced to the user in the store so that they can see that your app is going to make use of the web browser, or location, or networking, or whatever. As opposed to ID rec elements, which say that you absolutely require this feature, and so your app will not be made available to devices that don't have this feature. So if you say, I require a certain amount of memory, or I require a compass, then the device that's looking at the store won't see your app in the store unless it has those capabilities. For feature light-up, there's some support in the API. You can check various. Let me actually go to some code here. There's a kind of an example of the sort of thing I'm talking about. You can check gyroscope is supported, and accelerometer is supported, and is camera front-facing supported, and so on. And some of these are obviously fixed in the sense that you only need to check them once because they're not going to change on that device. But some of them can change dynamically, like is cellular data enabled, is data roaming enabled, is the device currently on AC power, what kind of network connection do I have? Those things can change. So for those things, you'd not only check them, but you would probably handle the nice events that get raised when they do change. And tile light-up is another kind of classic example of this. So you would do a check like, I thought I had some code. Wait a minute, it's over here. Let me switch to this device. There we go. This is more or less what I've just shown you, but I was just going to call out this. You would check for the current version that you're running on, and you would map it against known versions where there is a different feature set. Like if it's 7.0, that's the version number for 7.0. Between there and there is 7.0. Then between there and there is Mango. Between there and there is Tango, and so on. So you would check the version. And then if this is a version that supports, if current version greater than or equal to basically 7.8, then we know it supports enhanced live tiles, in which case we can go ahead and create an enhanced live tile which has 3 different sizes, a front and a back, and 3 different formats, iconic and flip and so on. And you'd obviously have to do that via reflection because you're compiling for 7. In this case, you're compiling for something sub 7.8, but you want it to run on devices that include 7.8 onwards. And if you're not running on a later version, then you just go ahead and create a standard tile. This is kind of the classic example, as I said. Reflection obviously is something that there's only 2 supported light up scenarios. And that's in-app purchase and enhanced tiles. So you should be wary of using reflection as a general tactic, because obviously, in theory, you can get to things that you shouldn't get to, like you can get to private members, for instance, but if it's not documented and it's not public, you shouldn't be touching it. And Rudy Hoon, who's an MVP, has produced this great reusable wrapper for this, so you don't even have to do this. You just use his thing, Mango Polo. It's great. Okay, let's look at the resource manager. So the purpose of the resource manager, it kind of parallels what I said earlier on about playing nice in the ecosystem. The purpose of the resource manager is to try and enforce some level of playing nice in the ecosystem. And it's changed over time. So in 7, it was a simpler mechanism which actually did allow an app to consume all memory on the system and basically to run away until it ran out of memory and crashed. To the exclusion of other things. In 8, we started to become a little more circumspect about things, so that we imposed constraints so that it does maintain some level of balance between all of the different things that the user expects to run all at the same time. We still prioritize the foreground app, the thing that the user last did, the thing they're actually interacting with right now, has higher priority in terms of CPU quota, has higher priority in terms of memory. But it's not all the memory on the system, and it's not all of the CPU either. And we divide up the rest amongst all of the other things that are running in the background with a notion of the different priorities. So, VoIP has a higher priority than a generic background agent, for example. GBA is pretty low on the priority stack. And we also have a notion of some things, if we're under extreme pressure, we won't necessarily allow everything to run that could run. So if we're under extreme pressure, the first thing that goes is typically GBAs and the backstack. The backstack, because we can always get it back. We know what was on the backstack. If the user sees a previous app in the backstack, we can always relaunch it from scratch. It'll be slightly slower to start, obviously, because that was the point of FAS in the first place. But we can still do it, so we can clean up the backstack if we need to. And we can prevent GBAs from running if we're under extreme pressure. So the resource manager maintains this balance. So it's not a totalitarian state. We maintain some level of balance, and then we leave it up to the apps to do the rest. And we manage memory, CPU, access to any contended sensor resource. so camera, microphone, speaker, audio pipeline, accelerometer, and so on. And we introduced paging a while back, and we continue to use paging very carefully because there are disadvantages to it. And I'll look at the different the matrix of caps and why they're different. So this is the baseline of caps for the things that you care about: foreground app, generic background agents, background audio, and VoIP. So these are all task types that you can create. And you can see they vary by device configuration. So we treat a low memory device differently from a high memory device. And that maps exactly now to 512 and 1 gig plus on Windows Phone 8. In Windows Phone 7, it was 256 meg and 512. So obviously it's a moving window. Although theoretically it's possible for a 1 gig device to be treated as a 512 meg device if that device happens to come with some overhead in its hardware support. So if it's got additional memory carve-out in order to support an extremely high-resolution camera, for example, then it might drop the memory that's actually available to the system after the carve-out. It might drop it to a point that we would treat it as a 512 meg device instead. So, raw physical memory isn't necessarily an indicator. Although, as I say, in practice right now, every single device does fit. It's either 512 or 1 gig plus, and it fits these low memory and high memory categories. I've got some asterisks in there as well because background audio and VoIP don't run at the same time. This is one of our trade-offs that we decided that you wouldn't be doing. The user wouldn't be doing a VoIP call and also playing background audio at the same time. It kind of doesn't make sense. So we don't run those at the same time. We don't run GBAs on a low memory device if there's a VoIP call ongoing. So that's one of the cases where we prevent those from launching. We'll queue them up so that it'll launch eventually, but not while the call's ongoing. Whereas with a high memory device, we do have enough spare capacity to allow the GBAs to continue to run. I've made the point there that caps are not quotas. That's almost a splitting hairs here. If you look at the certification requirements, it does say you must not try to use more than 90 meg. So 90 meg is kind of still our only real guarantee that we'll give you 90 meg. But in practice, we will do our very best to give you whatever we said the cap is for that device. So if the cap is, the baseline is 150, so it's going to be an extremely rare scenario where we can't give you 150 for the foreground app. So it's not really a quota, it's not a guarantee, but it's sort of almost a guarantee, if that makes sense. And it's still true that the vast majority of apps are well below the baseline default cap of 150. So you've seen already that we turn off GBA sometimes, we turn off background audio sometimes. There's a fair amount of juggling goes on. These numbers are kind of ballpark approximations. They don't necessarily correspond directly to real devices. But you can see the sort of patterns that on a low memory Windows Phone 7 device is a 256 meg device. The BSP took up some number of megabytes. The OS itself takes up a certain amount. Then there's an allocation for drivers, for system services, for system caches, various buffers of one kind and another. The start screen app. So then below the line is what you've got left to play with. So can I take questions at the end, because I'm going to need you to come up to the microphone and all that kind of stuff, so it'll be simpler. And I might actually answer your question on the way anyway, but don't let me forget. So So there's stuff running, there's stuff that you might not be aware of running, like there are background agents that are installed by the OEM and the MO, possibly, not always, possibly. And they will be running in addition to GBAs that you might have created. So we're left with a certain amount of physical memory. Then we peg paging at a certain level. We run endless tests with the entire catalog to kind of gauge the behavior of apps with different levels of paging. And on Windows Phone 7, we decided it was somewhere around 50 or 60 or 70 maybe meg of paging was acceptable before it started impacting the user experience, before there was a noticeable slowdown in transitions. And in Windows Phone 8, we decided that there was a higher level was acceptable because everything had got a bit faster, paging had got better. A key difference up here as well is that you can see clearly the OS became significantly bigger between 7 and 8, which kind of explains the numbers at the bottom. This bottom line is what's left after everything else for the foreground app and the backstack and continuous background execution. And we're worse off in a Windows Phone 8 low memory device than we were in a Windows Phone 7 high memory device, even though they both have 512 meg of memory. Mainly because the OS is so much bigger. And this is part of the penalty of converging on a single platform, a single kernel. But again, we've done endless app compat tests. The catalog just mostly works. These are the worst case scenario as well. We established the caps based on firstly a notion of what would happen in the worst case, where if everything that could run did run at the same time. So we had foreground app, we had VoIP, we had CBE, we had background audio, not background audio, but we had a GBA, we had OEM and MO background agents, all running at the same time. And also all consuming their maximum cap immediately. If that were to happen, we'd actually be under severe pressure, and we would have to start killing things. We'd have to flush the backstack. We'd probably have to delay GBAs. But it doesn't happen. It's not a realistic scenario. Apps don't consume their entire cap immediately, and not all of these things do run all at the same time anyway. So in, again, a very high percentage of cases, we're actually fine with a model that basically overbooks memory. This is the same thing in pictures. So some things that you can do. Use memory APIs to check how much memory check what the caps are, check how much is on the device, check what your current consumption is, check what your peak consumption is, and clean up memory whenever you can. Particularly if you're monitoring your memory usage, either just as part of development during debug, as an additional sort of profiling mechanism, or actually during release as well. You're monitoring your usage, and you can clean up stuff when you're not using it if you get to a dangerous threshold. Which features in your app are consumptive of memory. You know where the hotspots are. Other things you can use, obviously, I've mentioned already, check for features that the user has disabled because there's no point loading up that additional DLL if they're not going to use that feature. Image resolution, and in fact screen resolution, two somewhat different issues, or two different aspects of the same issue, I guess. Use launchers instead of full controls. This list is kind of, I'm hoping is not news to most of you. And Stefan will talk about all of these things in detail tomorrow. But just to mention them briefly, launchers instead of full controls, I mean things like use the web browser task instead of the full-blown web browser control. Use the Bing Maps task instead of the Bing Maps control because they're much smaller. Consider tuning your page transitions. So if you're on a 1 gig device or a 2 gig device with loads of spare memory, fast process, then use page transitions. If you find yourself running on a 512 meg device, then perhaps turn those off. All of our lists, the list box, the long list selector, they're all virtualized now, but you can also do your own paging, your own load on demand. Test, obviously, on all of the emulator images that you're targeting. The default in Windows Phone 8 is the 512 WVGA image, and it was deliberately the default so that we kind of force you to test on that lowest common denominator unless you choose not to target that. Obviously test on real devices because things are different. Nokia, you can sign up with Nokia to test on real devices in the cloud, which is a very useful strategy. We'll look at some of these. As I say, Stefan is going to focus more on them, but let's look at a few of these. Oh, app. Let me switch to an app. I can remember which one this is. Yes. So I'd have a little app here. It's not really doing anything interesting. It's just, you can see from the code here, it's just checking. It's calling the APIs to check memory consumption. What is the total on the device? What is the commit limit for this app on this device? The working set limit you can kind of ignore. I mean, that was a 7 feature because the working set was different from the commit. That's not true anymore, so you can pretty much ignore that. But you can see here, so I'm obviously running on a 512 device, and my commit limit is 150. And my peak at the moment was 5.3. Currently, I'm using 5.23. The managed heap is less, because obviously the amount of memory ascribed to the process is to the process. It's not just to the app, it's to the whole process, which includes native code in there as well as the managed heap. So that the managed heap, which is a report from GC, get total memory, is always going to be lower than the memory of your process. And it's the memory of your process that counts against your cap. So all I'm doing here is I've got a function that kind of simulates doing stuff that I know is going to consume memory. So I just merrily go along and consume memory. And all I'm doing in here is, you can see I'm just grabbing a huge array of bytes every time. And it keeps going up and it keeps going up. But I'm watching what's happening. So when I get to what I consider a dangerous threshold, I mean, obviously all I've done here is change the color of the text, but my point is that you can watch this and you can decide what your dangerous threshold is. I've said in my code here, where is it? I said, oh, here we go. When I get above 75% of my cap, then change it from lime green to orange. And when I get to 90% of my cap, then change it to red. So the changing the color is kind of a proxy for do something to release memory at this point. But I can keep going up and keep trying to consume. Obviously, I get to a certain point and I'm not going to be given any more memory because I've hit my cap. And the other thing, obviously, is that when I'm doing this consume memory thing, I'm doing it in a try-catch block and catching the out-of-memory exceptions. And if you don't catch the out-of-memory exception, it's like any other unhandled exception. If you allow it to propagate out, we'll notice that you've allowed this to propagate out. We'll take a Watson and we'll terminate you. So, don't allow it to propagate out. It's a combination of profiling and this sort of mechanism. I mean, you can see I've got a really simple log memory usage, which is just debug.writeLine, find out what my current and peak memory is. At the beginning of method or feature where I think I'm going to be using a lot of memory. And you can combine this with the profiler. I mean, obviously, debug.writeLine gives you a lot more scope about how you format it and where you do it, and you can correlate it more closely with particular calls. Using the profiler is sometimes a little more difficult to match up the timing of things. So, as I say, I'm catching the exception, and I can obviously carry on regardless, and the app is no worse the wear. I can just continue to go down and up. So, a couple of points about this. If it's a managed app, obviously, you catch the out-of-memory exception. If it's a native app, then you're doing something to allocate memory. You're doing a virtual alloc of some kind underneath, and you'll get a null pointer back. And if you don't handle a null pointer, then the same applies. It'll be basically an unhandled exception. Will Watson and terminate you. So either way, you handle the memory allocation failure, and you can recover. For the managed framework, the resource manager does actually issue a low memory warning. We have a notion of somewhere around 15% below the cap. It varies according to what the task type is, but somewhere around 10 or 15% below the cap. We'll send a warning to the framework to say, memory for this process is getting low, you might want to do a GC at this point. So the framework takes care of that and does a GC on your behalf. That's not exposed to the app. And obviously there is a small chance of failures that are completely outside your control, because underneath the managed stack and down at the bottom somewhere, something in the native stack could fail and not propagate up, and you don't get a chance to handle that at all. So SOL for that, unfortunately. But that's extremely rare, and you could argue that that's just a bug in our platform. So of course it doesn't happen very often. There's just a summary of multiple runs. As I said, you target every device that you're planning to market for. So you target or use the emulators if you can't use real devices. And this is the sort of patterns you would expect, that depending on the version of the platform, depending on the configuration of the device, how much memory it's got, then you will get different results for things like the commit limit and the working set limit. But the app itself is pretty stable. I mean, this app obviously didn't do anything, so you would expect that. And those are some of the code. The device status class, which is kind of a slightly newer version of the device extended properties class. The device extended properties was this kind of random property bag-based dumping ground for anything that we couldn't fit in anywhere else. And then we morphed that into the device status class. And unfortunately, that then became kind of this generic dumping ground for everything that we couldn't put anywhere else. So in Windows Phone 8, we introduced things like the memory manager class to try and provide more structure to this arbitrary information. So the memory manager process committed limit is exactly the same as the device status application memory usage limit. It always gives you exactly the same number. And the process committed bytes is always exactly the same as the application current memory usage. You use either. And going forwards, we'd like you to use the memory manager, but it's 8 only. Memory cap options. We set default caps for everything, and including the foreground app. But for the foreground app specifically, we allow you to opt into a higher cap because we recognize that we pick a number for the default that we think provides the optimal balance of user experiences across all of the scenarios that the user expects, of all the different things that can be running all at the same time. But we recognize that sometimes there are some apps that just need a bit more. So this should be an unusual case, but if you do need more, you can ask for more, and we'll give you more. There's no conditions attached to it. You ask for it, you get it. But again, don't forget that caps are not quotas. I mean, asking for more doesn't mean we never pre-allocate. So if you ask for it and you don't use it, then it makes no difference, right? There's 2 entries that you can put in your manifest. ID func cap extend mem. This is a functional capability. You're asking for extended memory. You're asking for the higher cap. And as I say, if you put that in your manifest, we'll just give you the higher cap. And exactly what the higher cap is depends on the type of app you are and the configuration of the device, how much memory the device has. So XAML apps get higher caps because they suffer from auto-scaling of the UI, which native and XNA apps don't. So XAML apps need more memory. That's why their cap is higher. And the other entry you can put in the manifest is an ID rec to say, I require 300. And what that's saying is, I do not want to be visible to a device that only has 512 physical. So if you've done all you can to tune your memory usage and you still don't fit, and even asking for the higher cap is still not enough, then you can ask to be opted out. And then, like any other requirement, your app will just not be visible to devices that don't have that capability. And obviously, we'd prefer you not to do that. We'd prefer all apps to be available for all devices, and I'm sure you probably would as well. But, and it's not the end of the world. There are some apps, there are some fairly high-profile apps that originally opted out, partly because of just the scheduling logistics moving from 7 to 8. Everybody's got a lot of work to do in porting. And so this is one of the things where, they just couldn't quite get it to fit in the time, but then produced an update shortly after and removed this requirement because they did then fit into 512 devices. So you can put it in and take it out. As I say, just a couple of manifest entries. ID rec memory 90 was the old one for Tango 256. It's sort of redundant. If you can put both 90 and 300 in if you want, we just ignore the 90. So it doesn't make any difference if you leave it in. The positioning of the entries in the manifest is important, and they go in a particular place, and it's different between a 7 manifest and an 8 manifest. But you can look that up on MSDN. Screen resolution is another thing to think about. This is just a kind of a back-of-the-napkin calculation. If you think that, well, okay, full screen resolution, if I'm updating my entire screen every time, which hopefully you're not, you're just updating portions of your screen, but let's say you are, then at WVGA you're taking up nearly 1.5 meg of memory for a single frame. And the system uses multiple buffers, potentially 5 buffers, not always 5, sometimes it's less than that. There are cases for some apps that it's actually more than that, but mostly it's 5 or less. But you can see that's 7 meg of memory. And if you've got full WXGA screens, then you could be taking up 19 meg of memory just without knowing. Multi-res images, slightly different issue, but related. So you know that you can target multiple resolutions. You should check to see what resolution you're running on at runtime and only load the images that correspond to that resolution, because again, there'll be savings in memory if you can use the lower resolutions. Oh yes, a demo. So I was just going to show you something really trivial. Something really easy to do or not to do. So by default, if you don't pay attention, you could be using an awful lot of memory. But fortunately, the fix is really easy. So here I've got an app. It's giving the user a choice. Obviously, this is a very artificial app. But it's giving the user a choice of different image sizes to load. And if we look at the app, I've actually got resources of different image sizes, including the original photo that I took, which is 5184 by 3456, big image. So we'll see what the effect on memory is. Right now, with no image loaded, I have about 18 meg of memory. If I pick an image that's exactly the size of the control that I've got here, then it goes up by half a meg, 3/4, not a lot. I'll skip thumbnail for a second. If I go to WVGA, so even though the image controller is the same size, I'm obviously now having to load the thing into memory and have it scaled. So even though it's much bigger, it's still going to end up the same size. And commit goes up a bit more. You know, you would expect the kind of trajectory here. If I load the original image, I've suddenly spiked at 60, 61 meg, just loading one image, because I'm not paying attention, or I'm reckless, or I just didn't know. Fortunately, you know, so one moral of this story is to use images of the resolution and of the size that you're actually going to display and not have scaling happen. But there's an even better answer. I'm just going to check this checkbox. And if I now pick my original image size, it doesn't really go up much at all. So even though I'm still loading this huge image, I'll show you what's happening here. I'm saying, well, if that checkbox is on, call this method, otherwise call that method. So the original method is, here I am loading this huge image. But if I got that checkbox checked on, I'm still loading this huge image. The difference is that I'm setting decode pixel width and decode pixel height, which makes all the difference in the world. It means that the decoding is done based on the target that you specify instead of the source. So kind of a trick demo, really. But the point is that if you're not paying attention, there could be some really small part of the API that you just didn't notice, and that can make a huge difference to your memory consumption. This is just an example run of that. And that's pretty much it. So the moral of the story overall, as I say, is assuming you do want to target the widest range, you still have a responsibility to target the widest range and produce a good experience. And secondly, you have to play nice in the ecosystem. Well, you don't have to, but it'd be nice if you played nice. Otherwise, the user will soon notice that your app is not a nice app. And there's various ways that you can slice it using the API, using the store, using static elements in your manifest, and using the profiler. And that's it. So, if anyone is still awake, thank you.